Welcome back, everyone. Ready to dive into something pretty cool in the world of LLMs.
Definitely. Always up for exploring the latest and greatest.
Today, it's all about automatic reasoning and tool use, or ART for short.
Ah, art. I've been hearing that name pop up more and more. Sounds like it could be a game changer.
From the research I've been doing, it seems like it might just be. Essentially, it's about giving these AI systems a major upgrade in how they tackle complex problems.
And when we say complex problems, we're talking about the kind of stuff that even trips up today's most advanced LLMs, right?
Exactly. So before we get into all the nitty-gritty of RT, can you give us a quick rundown on the limitations of current LLMs? What are the pain points they're still struggling with?
Sure. So LLMs, they're amazing at spotting patterns in huge data sets. That's why they're so good at things like generating different creative text formats, translations, you name it. But where they hit a wall is when you ask them to reason through multiple steps or use information that's constantly changing, which, let's face it, is something we humans do almost without thinking.
It's like that idea we were kicking around earlier about planning a cross-country road trip.
Right, you've got real-time traffic updates to factor in, weather conditions, maybe even figuring out the best detours for those quirky roadside attractions.
Exactly. LLMs might be able to access each piece of info individually, but putting it all together into a solid plan, especially one that needs to adapt on the fly, that's where they fall short.
It's a real challenge. And
Yeah.
that's precisely where this whole tool use concept comes in. We're talking about giving these LLMs a toolbox, a set of resources they can tap into to interact with the world in a much more sophisticated way.
So instead of just chewing on text, they can now actually use external tools like search engines, calculators, even code execution to solve problems.
You got it. It's like giving an LLM the ability to not just read a recipe, but to actually follow the steps, use the kitchen appliances, and tweak the cooking time based on what's happening in real time.
That analogy makes perfect sense. So they're not trying to memorize every possible outcome. Instead, they can access and process information in a way that's way closer to how we think.
Exactly. And art lays out the framework for doing just that. But before we unpack how art actually works, it helps to understand an earlier technique called chain of thought prompting. Have you heard of that?
Yeah, chain of thought. Isn't that where you're basically asking the LLM to show its work, like back in our school days?
Bingo. It's like when your math teacher would say, show your work, don't just give me the answer.
Right, you had to prove you understood the process, not just memorize the solution.
Exactly. With chain of thought, or CATI for short, you're guiding the LLM to generate that step-by-step reasoning process to get to the solution.
Which ideally should make the LLM more reliable, right?
That's the idea. Make it more transparent, more accountable for its answers.
But like anything in life, there are always those unexpected hiccups.
You said it. One of the big ones with OT is that if even one step in that chain of reasoning is off, the whole thing can go haywire.
Oh, so it's like a domino effect.
Exactly. And this can lead to what we call hallucinations, where the LLM starts spitting out incorrect or even totally nonsensical info based on that initial error.
It's like that recipe where if you misread one ingredient or measurement, the whole dish is
That's
ruined.
a perfect analogy.
Ah!
And that's a major issue that Artie aims to solve.
Okay, I'm hooked. Let's unpack this RT thing.
Mm.
How does it actually empower LLMs to use tools in such a sophisticated way?
Well, picture this. We give an LLM a super complex physics problem to solve.
Okay, I'm envisioning equations, formulas, the whole nine yards.
Now imagine this LLM has access to a massive Cask library. Think of it like a searchable database of problem-solving strategies, like a giant collection of solved problems.
So instead of starting from square one every time, the LLM can now be like, hold on, I've seen a problem like this before. Let me see how I tackled it.
Precisely. And that is actually the first crucial step of the RT framework: task decomposition and demonstration selection. The LLM checks out the new problem, breaks it down into smaller parts, and then digs into its task library for similar problems and the methods used to crack them. It's like having a whole archive of case files, but for solving tough problems.
And I'm guessing it's not just copying and pasting the answer from a past case, right?
You're right, it's more about picking up the problem-solving strategies themselves.
So it's learning how to think like an expert in that field, not just regurgitating facts.
Exactly. And this is where things get really interesting. It's called programmatic reasoning.
Programmatic reasoning sounds a little intimidating, like something out of a sci-fi movie.
It might sound fancy, but it's actually pretty straightforward. The LLM takes those examples from the task library and uses them to build a step-by-step plan to solve the new problem.
So it's like creating a custom program, a set of instructions specifically for this problem based on what's worked before.
You got it. And here's where that tool use we've been talking about really comes into play. Let's say the plan needs a specific physics formula, or constant, for example.
Which, let's be honest, most physics problems usually do.
Right. Now, instead of trying to guess or hallucinate that formula, the LLM can actually use a tool, like a search engine, to find the exact info it needs.
So it takes a quick detour to do some research, but then it plugs that info right back into its calculations.
Exactly. It pauses, accesses the tool, grabs the information, and seamlessly integrates it back into its process.
Like having a super efficient research assistant who fetches whatever you need right when you need it.
Exactly. And
Right.
because this tool use is baked right into the LLM's reasoning, it's far less likely to make those errors or go off on those hallucinations we were talking about earlier.
Makes sense. It can double check its work against real world info, less room for making stuff up.
Precisely. It
Oh.
keeps the LLM grounded and on track.
And this ability to use tools on the fly, it's what allows LLMs with RE to achieve what's called zero-shot generalization, right?
You got it. It means they can tackle brand new problems, stuff they've never seen before, without needing specific training on those exact problems.
That's a pretty big deal, right? Zero-shot generalization, it almost sounds like a superpower.
It's a game changer for sure. It means these LLMs can adapt and apply their knowledge in ways we haven't seen before.
So it's not just theoretical, this actually works in practice.
It's not just talk. Researchers have put RT to the test on some serious benchmarks. Think of them like standardized tests for AI.
How did it do? Spill the tea.
Well, on benchmarks like Big Bench and MMLU, which are designed to really push an LLM's reasoning abilities, ART blew past previous methods by a solid margin.
We're talking like a little nudge ahead or a significant leap.
We're talking significant. In some cases, it even outperformed systems where humans painstakingly crafted the reasoning steps by hand.
Wow, that's seriously impressive. So it's not just more adaptable and less prone to errors, it's objectively better at solving these complex problems.
Exactly. It's like RT unlocks a new level of performance we hadn't seen before.
This is really exciting stuff. But before we get too carried away, I'm curious about something. You mentioned earlier that RT is designed to be adaptable, to incorporate human feedback. What does that look like in practice?
Okay, so let's say our LLM is working on that physics problem, right? And it gets the number right, but forgets to include the units.
Classic mistake. We've all been there.
Exactly. With RT, a user can easily pop in and add a simple reminder to that task library. Something like, hey, don't forget those units in the final answer.
A little nudge in the right direction.
Exactly. And the really cool part, this feedback doesn't require retraining the entire LLM from scratch.
So it's not like starting over from square one every time you need to make a tweak.
You got it. You're just adding more info, refining those problem-solving strategies in that task library, making it even more powerful for tackling future challenges.
This is blowing my mind a little bit, to be honest. It sounds like art could be applied in so many fields, not just physics. But before we go down that rabbit hole, I'm curious how it stacks up against other techniques we've heard about, like RAG, or retrieval augmented generation. How does art differ from something like RAG?
Great question. RAG is a really cool approach in its own right, especially for tasks that involve pulling out specific info from massive data sets. Think of it like having a super efficient librarian who can quickly find the exact books you need from a giant library.
So ARG is about finding the right info, but art is more about using that info to reason and problem solve in a structured way, almost like a detective. So RH is like the research assistant gathering the data, and Artie is the expert using that data to connect the dots and crack the case.
Exactly. Both super valuable in their own ways, and sometimes they even team up. But what really sets RT apart is it's not just about finding or processing info, it's about using that info to actually take action, to solve problems, almost like we do.
It's like bridging that gap between AI and how we solve problems in the real world.
Right. We're moving past those early days of LLMs just generating text or translating. Now they're stepping up to help us tackle some of those bigger challenges we face.
It really feels like a whole new era of AI.
Absolutely. And with these leaps in reasoning and tool use, think of the possibilities in fields like, say, medicine. LLMs could be analyzing patient data, scanning through medical databases, basically giving doctors a helping hand to make those diagnoses even more accurate.
Or even scientific research. Imagine them sifting through tons of data, picking out those hidden patterns, even suggesting new hypotheses.
Right. Like having a tireless AI assistant working around the clock to push the boundaries of what we know.
It's pretty mind-blowing when you think about it, but we've got to admit, it's still early days.
Oh, for sure. As with anything new, we're bound to hit some bumps in the road.
We've got those challenges to overcome, ethical stuff to figure out as we bring these advanced AI systems into our world.
Absolutely. It's on all of us to make sure these powerful tools are developed and used in a way that benefits everyone, right?
Couldn't agree more. We've got to be mindful of things like bias, transparency, accountability, all that good stuff as we keep pushing the limits of what AI can do.
It's a conversation we need to be having right alongside all these amazing tech advancements.
At the end of the day, it's about creating a future where AI and humans work together, right? To build something better for everyone.
Well said. It's a really exciting time to be in this field, and I'm really optimistic about the good these technologies can do if we handle them responsibly.
It definitely feels like we're standing on the edge of something big, a whole new era of AI innovation. I can't wait to see what's next.
Me too. The possibilities seem endless at this point.
And that's a wrap for today's deep dive into the world of automatic reasoning and tool use. We hope you enjoyed exploring this new frontier with us and that you're just as amazed as we are by what it could mean for the future of AI. Until next time, keep those minds curious, and we'll catch you on our next deep dive into the world of cutting-edge technology.